Good morning and welcome to software engineering tutorial session. Today in this session I will be completing sheet 2, which is an ER diagram. Okay, so before we begin, if you have any questions from the previous problems, you can ask me. Faisal, is it clear everything from the previous sheets? Hope you are able to listen my voice. Okay, that's great. So let me start from the point where we have stopped in the previous week. Sheet 2 ER diagram. Let me upload that file for you. So here we go. Okay, dear, you can see the sheet. You can download that sheet too. Okay, it's available. Do you see sheet 2 I have uploaded? Sheet 1 already we have finished it. I'm talking about sheet 2. Yeah, so you can download this sheet and keep it ready so that from this sheet we will be solving the problems. Okay. At the top left corner, you see the zoom in and zoom out button. You can use the zoom in thing, okay, for bigger the screen. Okay, just click on that left topmost button. It will be, in big. Just try it out. Do you able to increase the screen now? And the term, yeah, that's great. So let me start the session now. I think we have completed problem 1 also, problem 2 also. Yeah. So we are on the way to solve this problem number. Just to give it a bit of time, it is taking some time to get loaded. Yeah. So let us start from the point where we have stopped in the previous session. So if you have any questions, you can type here, okay, so that I can start the recorded lecture now. And I think you might have seen the announcement also that you have quiz, okay? So you have to complete your quiz also on time. Already you can go and check in the announcements in the lecture folder. I have given you the schedule. Okay, first quiz will be in week 6. Then second quiz will be in week 8, right? Third quiz will be in week 9. Like this, we have total 5 quizzes, and each quiz carry 2 marks. Okay, so make sure that you don't miss any of the quizzes, because every quiz has 2 marks. Total 5 quizzes, 10 marks will be given for the quizzes. Okay, so I'm starting, so be ready now. So you can increase the screen size by clicking on zoom button. Good afternoon and welcome to software engineering tutorial session. In this session we'll be solving the remaining problems of sheet 2, that is ER diagram. Okay, so my voice is audible to you? Do you able to hear my voice? Nasser?
Yes, sir, welcome.
Okay, thank you. Okay, let's begin. Now see here, up to problem 8 we have solved in the previous session. Now we will see problem number 9. According to this, given an ER diagram, there is more than one approach. Okay, there are more than one approach to translate an ER diagram to relational schema. ER diagram to relational schema. What do you mean by? See, this is your ER diagram. Okay, you have to convert this ER diagram into relational schema is nothing but convert it into table, our database. Okay, try to look for a relational schema, that is write query that closely approximates to the ER diagram. Write query that closely uh, approximates to the ER diagram. So how you will do that? You see he has given an entity. What is the name of an entity here? Student. Okay, and what are the attributes associated? MN, name, age, and email. So when these things are given, now what you are supposed to do is you have to write a query to that approximates this ER diagram. So for that, what we will do is, you see actually in ER diagram, okay, in ER diagram, you have an entity, right? So we will use this entity as a table name. Table name. And attributes of an entity. Attributes of entity, they are nothing but the columns in the table. columns in the so I'm just giving here diagram is not given, just draw this diagram. So you see the diagram look like this. You have a table and name of the table is called student. Okay, and this student table has columns. One is called MN. Okay, and next is called name, age, email. You see here MN is having underline. This underline is nothing but, okay, MN should be a primary key. So this is the diagram. Now we will write a database command, a SQL command for this. Already we learned that. What is that? Create table. Create table. Name of the table is students. Okay, open bracket. Now we give this MN, suppose some integer. Okay. Name is some varchar to some 50. Okay, and age is some integer, and email is some varchar 50 comma, and important thing is primary key. Okay, you have to decide primary key. Primary is MN. Close bracket, put semicolon. Okay, this is the query. This semicolon. Okay, so this is the solution for 9th problem. Okay, it's clear? Is the solution clear? Already we have seen this, how to write queries for creating table and all. Okay. Here in this software engineering tutorial, in ER diagram, we are seeing only at high level. We are not seeing how to insert values in the table, which I already have shown you how to create table, insert values in the table. In many projects, I have shown it all for the project discussions. Okay. So is it clear up to here? Any questions?
Doctor.
Yes.
Entity, what's the meaning? And right?
Yeah, entity it's called table name. Name of the jadwal. Yeah.
Yes.
Okay, shall I go for next thing?
Yes, it's clear.
Okay, that's great. Now you see, here is a solution for that. But in the solution, you don't see the diagram, so that's why I draw the diagram. You see, create table students. MN is, yeah, there I have used an integer. Here it has used an character. You should decide it, is it a character or an integer, okay? And name is, I have used varchar and here it is using char. As I've told you, workchar is better than char. Okay, char will always take 20 memory locations. If you use workchar, if the name is less than 20, it will allocate that much memory. Okay, we have seen in the project discussion about all these integer and characters, all these things. Okay, so email also, and then primary key, and you just here you should put some semicolon. Okay, then you have to execute this query. It creates a table. So now let's see the 10th problem.
Your,
Yeah.
what's the meaning MN?
It's given some variable, MN, like ID number, ID like that.
Okay.
Yeah, ID of a student. Okay. Yeah. Now, see here. Let us try to solve this problem number 10. Given an ER diagram with mapping relationship sets, there is no key constraints. There is more than one approach to translate an ER diagram, of course, to the relational schema. Try to look for the relational schema with a query that closely approximates to the ER design. Yeah. Now you see here he has given this ER diagram. By seeing this ER diagram, we have to write a query that closely approximates that. For that, first, before that, I will give you the diagram, how it look likes. Okay, so that is very important. First, we have to write the diagram for it. Okay, so you see you have how many entities here? 2 entities. Okay, so as I have told you in the previous session, this 10th solution. Okay, that entity is converted into relational schema with table name. Okay, and second thing is, if you have a relation also, that will also be written in the form of table. Okay, you see students is having 3 attributes, MN, name, and email here. Okay, so what I will do is I will write here a table called student. The name of this table called student. Listen carefully. Is it student or students? Students. So I write it as students, and it has MN, name, and email. MN is nothing but some ID. MN, name, and email. Okay, this is the table. Next is you have a course. Course is also a table which is having 3 columns. Code, like course is software engineering, its code is E511. Okay, name is software engineering, year is this 1432, 1442 history, like that. So you have course also as a table. See, these diagrams are not in the solution. You have to draw this. This is called courses. It has what is this? Code name and year. So code name year. Okay, and we know that according to this ER diagram, MN is the primary key and code is the primary key here. Okay, so this is the primary key and this is primary key here. Okay, but see, there is one relationship called takes. Okay, now takes is also a table. It's a relationship. Relationship also is stored in the relational schema in form of table. Okay, but you see, it has one attribute called mark. When it has some attributes at mark, only one attribute, then we will see at left hand side and the right hand side. Okay, and left hand side of this relationship, okay, what is the primary key you have? Okay, will be also the primary key in the text table. Okay, but how we will get primary key for this text table? It will take primary key of both student and courses. Primary key here is MN and courses is code. So it will take both as of their primary key. Both attributes are primary key, but actually not existing in text. It is referencing to some M1, and code is referencing to some other table called courses. So when I just draw this table, you'll understand. You'll see here takes. We have another relationship called takes. This table called takes. Now the takes is having only one attribute, what is called that mark. Okay, but if I write some mark is suppose 50 or 70, okay, this mark belongs to which student? We don't know. Okay, so it means we need to know the student also. So you see left hand side, okay, you have a student table. So how do you identify a student? With one attribute using the primary key of student. Okay, so it means take should also have MN, that is the primary key. Okay, it should has MN, a primary key. And okay, if I write here Abdullah name and mark is 75, but Abdullah is having 75, but in which course? That also no. How you uniquely identify a course with the help of course code. So therefore, text will also have primary key of courses, that is called code. Okay, but here both are primary key, both columns are primary key, but this MN is actually referencing to, it's a foreign key referencing to students, and code is also a foreign key which is referencing to code of courses. Understood? This is the diagram. Is it clear up to here, all of you? Is it clear?
Doctor,
Yeah.
it's meaning make the table, the medium table.
Yeah.
Take the K from student entity.
Yes.
And
yes.
course
Also
together.
from the course. Yes. The column names will. So it means that only this text is having only one attribute called mark. Okay, but the own attribute is only mark. You see here, only one mark, right?
Yes.
But this
Yes.
mark is identified with the help of foreign keys MN and code. MN and code, they are actually foreign keys. That is, they belongs to some other table, and this MN is referencing to that foreign key in the student table, and this code is a foreign key that references to the courses. Okay.
Okay, it's clear. But Doctor, create table text. It's given.
No, it's not given. You have to write. The question is, Sawal is only up to here. Okay, your question is up to here only. Okay.
But how
yeah,
write
this? Yeah. So first you have to draw the by seeing this, you have to draw the diagram first, like this. Okay, you understood this?
Give me example, Doctor.
Yeah, example only I'm giving. Just by seeing this diagram. Okay, I have drawn this diagram. Correct?
Yes.
Yeah. Now by seeing this diagram, we will write query now. You see how I will write query. Okay. Now look here. First, I have to create the students table. So I will write create table. Create table. Okay. MN. Okay. What is this? Let us take this MN. I write name of the table as students. Open bracket. Okay. Open bracket. I write code. Suppose some char 10. Yeah. Any question?
Yes, can you again, because your voice cutting.
Okay. I repeat once again. This student, by seeing this table, I created a student table. Okay, where MN is the primary key and name and email are other two attributes which are of size varchar 50. Okay, and by seeing this table, I am just creating another table called courses. Okay, it is having three attributes: code and name and year. Here you can put date or some integer, whatever you want. So let's write this as a varchar only. Varchar, suppose I have taken some 10. Okay. Now after this, what is the primary key here? Code. Okay, so write primary key. Primary key is code. Finish. Now I have to write a query. By seeing this table, I have to write a query for creating table called text. Okay. So, but already I have given this query. So you see, instead of writing here, I write here above. Okay. So you see here, I have created a table, create table text. Okay. You have mn char 8. Okay. Now you should be very careful that if you are using char 8, then make sure that this char is also 8. Okay. So what I will do is, I will make this and make it 8 only. Okay. This is very important. Alternately, I just did this because you should understand why I am writing 8, because we are writing here also 8. Okay. Then code is char 20, but code, you see what we have written, code, this is char 10. No, so make it 20. Okay. Okay. So we have code clarity, and mark is integer. Of course, this mark is integer. So it has 3. But what is primary key? Primary key is m comma n. So primary key is mn comma code. Mn comma code. Both attributes constitutes to be a primary key in this. Okay. But what is mn? What is mn? Mn, it's a foreign key that references to students. Mn of the students table, right? So that's why we write foreign key mn. Mn is foreign key references to students. Okay, these references to students. Similarly, code is also a foreign key. Foreign key is code references to courses. Okay, finish. This is very simple. Just writing down the theory is very simple and drawing this diagram. Now, do you understand this? Is it clear?
Doctor,
Yeah.
for the 820, how find it?
No, we have to decide it like this. For example, MN is your ID. Your ID is how many characters big? You will write, for example, BD some 4, 5, 6, 7, 8. You see, you have Raham Jami. How much long it is? 8 or 10? Just see.
Okay, find anything.
Yeah, you have to see that generally their rule numbers are of 8 characters or 10 characters, 12 characters like that. So you have to decide. It's on you, right? So if you write 10 also, then write 10, 10, whatever you want. See, for name, I have taken, for example, you see in student's name, the name of every person, maybe I take 50 character. Okay. So generally it is less than 50 only. If you have more than 50 characters, you cannot write. You have to increase the memory here. Okay. For example, you have Abdullah Nasir, A, B, D, U, L, L, N, S. If you just count it, it will be less than 50 only. Correct?
Yes, it's clear, but Doctor, the answer, it's table and create a table.
Yeah.
Okay, 1 minute, just I will write.
Yeah, take that.
Doctor, can you make focus?
Yeah, it is not focused.
No, it's small.
Okay, you want to make it big? No problem. This, okay.
Yes, it's
Yeah.
clear.
If you are finished, let me know so that I can go
Yes,
for the next slide. Okay.
I finish. Thank you. I finished it.
Okay, that's great. So now let me go for another screen. Yeah, now 11th question. Given an ER diagram with mapping relationship sets, no key constraints, there's more than one approach to translate an ER diagram. No, actually, you see this is same. I think this is the 11th and 10th is same. It's the same table. I think the question is repeated 2 times. Okay, so we have solved it already. So let's go for 12th problem. Yeah. Now here comes the game. Given ER diagram with mapping relationship sets with key constraints he has given, you see this key constraints that is called total participation, and this is partial participation. Light bold line and normal line is there. Okay. Now we have to write a query that closely approximates this. So when this kind of thing is given, okay, you should do one thing. What is that? We have to assume the attributes here. The attributes are given here. Okay. So we will of service this directed by is the relationship between them. So for that, what is important is we need to assume the attributes of these tables. Okay. So let's do how we will create it. Okay. For that, you see, so far we were seeing. Yeah, look here. Generally, you see, student has, for example, it has an attribute called its ID, MN, and just I'm underlining this. Okay, and student has name.
Name.
Very good. And suppose an email. Okay.
And date.
Yeah. So I'm just writing small so that our query will not become big. Okay. And let's go for this department of service. Okay. Students are directed by department of service. In department of service, you'll have staff. Okay. Different teachers. So we call them as staff ID, for example. Staff underscore ID. Or you just write staff ID. Staff ID. Okay. And you will also have staff name. Okay. This name, staff name. And they have some salary also.
Those same the teacher.
Yeah, it's same. Let's give only 2, okay, to make simplicity. Okay, so that now I'll just show you how to. Here, what you have is how many tables you will get. Tell me. For students, you will get 1 table.
2 tables.
Yeah, and for department of service, you'll get another table. This, and for directed by, see, relationship is also there. Okay, so there also you will get 1 more table. 3 tables total you will get. Okay, so same thing. You will have a table like this. Okay, this is students, and you have MN. and name and email. Okay, and you have another table, department of service. You have staff ID and staff name. Okay, and directed by is another table. Directed underscore by. See, directed by is getting another table. Now, this has no attribute. Okay, so if it has no attribute, then it will have only two columns. One is the primary key of left side table, which is MN, and another is primary key of staff, DOS ID, staff ID. Okay, but if you have any attribute here, then you will mark in directed both of them are primary key. But here it has no attribute, so we will take primary key only left hand side. Okay, so only now I will write the query. You will understand. You see here, I'm just writing a query. Create table. Table name is students. Open bracket. So I will write MN. So MN is suppose this is some char 8, comma. I want to just make it a little bigger. Yeah. First you have MN. This is char 8, comma. Then we have name. This is I write var 50 and email var 50. Okay, so what is primary key? Primary key is MN. Close bracket. Finish. Now let us write queries for this table. Let's create. Now you see here. This is MN is a actually foreign key that references to the student here, and staff ID is also a foreign key that belongs to department of service. Okay, so here I will write create table. Create table. Name of the table is department of service. So you write staff ID. So what is staff ID? Let's take this also ID character of 8. Okay, and it has staff name. This is char 50. Okay, and then the primary key is staff ID. Okay, close this semicolon. Right now, let's write query for middle table. Create table. Name of the table is directed by open bracket. Now here you will have MM, which is char of 8, and you have staff ID. This is also char of 8. you have MN is actually foreign key that references to students. Okay, so you write foreign key is you have a foreign key, two foreign keys. One is MN and another is staff ID, but MN references to students, comma. Another foreign key called staff ID. This references department of service. Okay, but do you have any primary key here? Yes, of course. The primary key is only one attribute, so I'll write here primary key. Primary key is only MN. That's all. Okay, so this is finish. What?
Why in relation K it's MN just?
Yeah, because you see, you can easily identify that for this student who is the teacher, correct? So for 2-3 students you may have same teacher, but student will be different, right? So that's why MN only student is having a unique key, and staff ID is a primary key in DOS table, but not in the directed by table. Got it?
Again, Doctor, please.
See, your question is why MN is primary key and staff ID is not primary key. Is that right?
Yes, exactly.
Yeah. The reason is, so see here, this is having no attribute. Okay. Directed by is having no attribute. In the previous example, we have attribute here called mark. Do you remember? Yes. In the previous example, we have an attribute to the relationship.
Yes, yes.
Yeah, that's why we take primary key of left table and right table only. Correct?
Yes.
But now here it has no attribute, so that's why I take primary key of only left table. That's all. No need of taking right table. Got it?
But why, Doctor? Why take it from student, just not from us?
Yeah, that's just now I told you. See, 2 students may have 1 teacher, correct? But 2 students are different, and staff ID can repeat here. If I put primary key, if I put staff ID to be a primary key, I cannot repeat it. That is a problem. Understood? For example, you see, what do you mean by primary key first? In the last class, I have told you that suppose in this table, this is suppose student table. Suppose you have ID and name. Okay. Suppose ID is 1, name is Abdullah. Okay, it is accepted. Second is ID is 2, again name is Abdullah. It is also accepted because name is repeating. This is not a primary key, you can repeat. But again, if I put 2 and I write Abdurrahman also, this is wrong. This is not. Why? Because primary key cannot be repeated. Understood?
Yes, yes, yes.
Yeah, in the last class we have shown this. That's why you see, students should not repeat because there are different students here. Okay, for example, Nasir, okay, your ID is 1 and your teacher is Salman. And again, Walid is also there. Okay, his teacher is also Salman. So Salman can repeat here. Students should not repeat. Correct?
Yes, yes, Doctor. It's clear.
Yeah, that's why staff ID I didn't put primary key. If I put primary key, then for one student I will get only one teacher. And you see, students are more. How can I get all? If there are 20 students, 20 teachers, we cannot get. Understood?
Yes, yes. Clear.
Yeah, that's why we put it like this. Now it's clear.
Yes, but Doctor, what's the type for relation? Many to one?
Yeah. Now the relationship here is, you see, this is many, and this is also many, right? But all the students, okay, that belongs to, for a set of sections, they are directed to, they belongs to only one department of service. This is department. For example, what is department of service? For example, here this is his electrical department. Okay, EE. Okay, this EE, electrical department. So there are many departments. You have electrical, and you can have mechanical, civil. There are many departments, and students are also many. But all the students should belong to. They are different, many students. But you see, each and every student should belong to only one department. You cannot say that, okay, I'm Nasser, I belongs to electrical department. Sometimes civil department. Can you say like that? You cannot say. You'll say that always I belongs to electrical department, correct? So that this is the meaning of total participation, and the with this relationship, this is many to one relationship. Okay, and students to DOS, this is many to many relationship.
Yes, yes,
okay,
correct.
yeah. Now is it clear?
Yes, for me.
Okay. So anybody has any question, please ask me.
Question 11, same question 10, Doctor?
Yeah, it is same. It was a repeated question actually. See, this is same as ever. This is the repeated one. 10 and 11, they are repeated. Okay. So let's go for this is slide 30. Let's go for 14. Yeah, I think this is the solution. Just now I discussed the solution. You see, directed by primary key. You see, primary key is only one, right? Only one primary key, and foreign keys. Yeah. Third is, does the above solution capture the participation constraint? This is not capturing the participation constraint. The solution what I have given is not capturing the participation constraint. That is the thick arrow one. Okay. Now in this solution 3, same as above. Okay, but only you have to change one table, student table. Okay. For example, let me just change this. Open. Okay, now see here. Here I have given MN name and email. I will add just one more thing here. Okay, for this solution, because I will just add one more called age here. Okay, I'm adding age, and just write this. Age is equal to integer. Just add one more attribute here. Okay, it means I'm adding one more attribute called age. Why I'm adding? Because in the solution 14th, okay, it is useful. See, 14th is same as this table. This is same, directed by is same, and DOS is also same, but we will do only one change in this student table. You see what is that change? So let me select all.
This is question 13, Doctor?
This is 12. In 12, I'm just showing this 12 only. I have added just one attribute extra, and I will solve 13 with the help of this. Okay. So let me solve it. Oh. select all. Believe it, I will write again because now you see here. Just I made one extra thing in student, so that every student belongs to same. There are many students, there are many departments, but every student should belongs to one department only. Okay. So for that, I just added only this one here. You see, only this is added.
Here, doctor.
Yeah, this is okay.
Email. What means?
Email. It is.
Email.
Yeah. So you see, so here instead of char, you just write varchar. This is instead of 20, we generally use 50, correct? So let's write 50 here. Yeah. This is 50, and this is also 50. Okay, and same primary key. See, everything is same, but you see, primary key is MN. Okay, and foreign key is. I'll just show you. Look here. You have a student here. MN name, email, age. And you have staff ID, department of service, staff ID, name. This primary key here, this primary key here, and then here you have directed by. Here you have MN and you have staff ID. Here this is a primary key that references to MN. Okay, and here you are adding one more called staff ID in the student. See, this is the extra you are doing. Look here. Yeah, ready. Yeah, so just instead of DOS, I write here department ID, right? So you can write either staff ID or DOS ID. So I write here staff. Okay. So now this is reference to this MN, and staff ID is a foreign key, okay, which is referencing to this column staff ID, right? And this staff ID is a foreign key that belongs to like this. Everything same as previous answer, but only in student table you have two changes. First change is add one extra staff ID, and which is a actually one key that references to department of service. Okay, this is the change. That's all. If you do this change, then you ensure that it is a key constraint. You have captured the key constraints as well. This table is same how we have discussed in previous answer. This DOS is also same. Both tables are same. There is no change in this as previous answer. Only this is changed. Student table is changed. And you see how it is changed? I have shown here. See, student table is changed like this. Create table student. Okay, MN name, char, age, integer, email. Also, you take varchar. char 15. Okay, and we are adding one more attribute which is not null. It means you cannot leave this empty. There is no student that has no department. Okay, every student belongs to department. That is the meaning. Okay, and primary key. Is it clear? The solution is clear. Only change in the student. All these two tables are same. Okay.
Change in the AR diagram.
Yeah, change the AR diagram here. Only here. You see, the changes I'm just highlighting with yellow. This is change. Okay, and this is change.
Yes.
That's
The rule is constant.
What is constant?
The rule
Which rule?
from the draws, from the tables.
No, I didn't get your question properly. Can you explain again?
Idea from the tables, all tables in the screen is some like this method.
Yeah, it is same for all
Yes,
problems.
just different the variable.
Yeah,
different the
yes,
same like this.
Yeah, right. Yeah,
Okay.
you're right. Concept is same.
In AR diagram.
Yeah.
Stuff add with the dots with the student entity, correct?
No, it is same. You see, there is no change in directed by and DOS. Only in students you have change.
Yes, in the AR diagram, add.
Yeah, in AR diagram also it is changed. Correct.
Yes, but the same, but add in student stuff, correct?
Yeah, staff ID. Yeah, that's good. Great. That's correct.
يا شباب الفكرة الأرقام نفسها بس التوصيل يعني نفس هذه نفس المعاملات هذه.
Yeah, I didn't understood, Abdul Rahman. Can you just explain in English?
Excuse me. I'm sorry.
Yeah. Okay. Anything else to ask?
No, it's clear. Thank you.
Okay, welcome. So now let's go for. I think we have finished our sheet, but let's see, there is something left. So this is same as an ER diagram. So this you can take as an homework. This is some complex ER diagram I have given you. You can just create the tables. This is one table. How many tables you'll create? 1, 2, 3, 4, 5, 6 tables you will create, and each table is having the columns. And you see, we have to ensure that there is no attribute to this. So take primary key of left table. Here also there is no take primary key of only one table. Okay. Here also take primary key of one table. So total 6 tables you'll create. It isn't just an homework for practice. Okay. So let's go back to our project concepts now. Okay, from here we have completed sheet 2. So let me show you now some more commands in our SQL which we have seen.
Doctor, this question.
Yeah, this question.
Homework.
Yeah, you can solve at home at leisure. So just for your practice, if you are having interest, you can try to convert this into tables. You get 6 different tables and long columns. Okay. Generally, your project will be like this only. Okay. They will give you this ER diagram, and you have to convert this into tables. Okay.
Just the training. Don't send anything.
Yeah.
Thank
you. Okay. So now. Yeah, this is our SQL server. I'm just connecting it. So in the last class we have created one table only, right? About this employee table, okay, and each employee belongs to different department. Let us see that also. So see, this is our database. Just now we started, it is taking time. Now we have created one university database, right? In university database, I just created again a table called database diagrams. No, not now. Okay, so let's see here in storage, security, program service. I think, yeah, EMP table we have created. Do you see this EMP table? So now what we'll do is, so let's get back our, we'll create this new query. Now you see by default, we are using which database? See, we are using, yeah, university database. You see, it's showing here, university database, no problem. So no need to write use DB like that. If I want to use some Northwind database and all, I can use it. So let us write, I think we can open file, open the previous files. Last time, because those who have not attended the last class, they can see these queries, that how we have worked with it. So let's open this. So yeah, I just opened it. I'm just closing the new one. Yeah, see, in the last class we have seen that we have inserted all of them. Okay, and we have also seen how to pick the table. So we select all from EMP. I want to see that whether our table exists. Oh yeah, so we have just created this table last week, right? We have employee ID. As I have told you that employee ID is a primary key, right? You see this, we have created a table with the help of this diagram. So I'm getting some questions. Yeah. Any question? It's not an, it's just for practice I've given for you the last time. There's no. For you in project, okay? So now, again, one important thing is, you see, I want to see only employee ID and his gender, okay, and his salary. Only these three things. I don't want to see all the things, okay? So for that, what I will do is, okay, select. I want to see only employee ID and gender, okay, and I want to see salary of an employee, okay, from EMP, employee database, okay. Now he is giving error that invalid column name EID, okay. So why it's giving like this? I want to select only specific columns from the table. So for that, what I have to do, Let us see where is the mistake. Is it executing? Yeah, there's a mistake actually. So you see employee ID and gender and salary. Only these 3 columns I'm seeing. Correct? Yeah. Next is, okay, let's go back to select all. You have this big table. Okay. And I want to see like how many okay, males are there or females are there, or I want to see that whether it's only males are there or only females are there. I can filter them with the help of some distinct keyword. Okay, so like select. Okay, if I write EGENDER, gender, okay, from employee. If I write like this, you see, it will give you like this: male, male, female, female, male, 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 like that. You see? See, it's giving employee
Doctor.
ID one. Yeah.
Dr. Salman, assalamu alaikum.
Yes. Yes.
The program, no download my.
You have not downloaded? Yeah. So please go back to the mini project lectures I have put there. You can open the video, watch it, and try download it.
Yes, but refuse all times.
It
refuse. Yes.
It refuses.
Yes.
Saying what error message?
Okay.
No. What error it is giving you?
Different information. Last step is give me different information and heck.
Which operating system you are having?
Windows 10.
Okay, in Windows 10 it will be installed very easily. If you are having Windows 7 and 8, first you have to install Service Pack. See, please go back again to the video. In that I have shown you that before installation there are some installation instruction given. Okay, so click that link. It will install all service packs for that window. After that you install this, it will be easily installed. Okay, service packs you have to install first. Maybe that is missing in your operating system. Okay.
Okay.
Yeah.
Thank
so
you.
try install that, and it will solve your problem. Yeah. Now you see, this is giving first employee is male, second male, third is female, like that. Male, male, female, female. No, I want to see that how many types of genders are there. So use distinct. Distinct. If I use the word distinct, now you see it will give me total, genders. There is only 2 genders, male and female. Okay, this is one. This is clear, all of you up to here. Now, yeah, any question?
No, it's clear. The same idea the last lecture, correct?
Here I am showing you different distinct, how to select specific columns. Okay, it is not same as previous. I am showing you some extra commands for learning. Okay.
Okay.
Yeah. So now let's go back to. Yeah. Now you see here. I will just copy here. Okay, select all from EMP. When I execute this, you see you have employee table. Okay, I'm asking you one question. Okay, all of you, please tell me. Can you tell me the name of employees who are females?
Again, Doctor.
Tell me the name of the employees who are female.
to name.
Yeah, so to name and that. Now this is small table, it's very easily you can say. But suppose if this table is having some 1,000 records and all, how much difficult it will be for you, correct? It is very difficult for you to do that.
Yes.
So, yeah, with the help of query, you see from this table, I can just write like this. You see here, select all from EMP. Select all from EMP, where, okay, e-gender is equal to, so I'll write FEMALE. Okay, now you see, I run the command, you see directly I get it. Got it? This is the power of this. Okay, if I ask you from this employee table, tell me which employee is having salary greater than 10,000. Some conditions, okay, or less than some 40,000, like that. So for that you need to put some multiple conditions, right? So for that we will be using where along with and or there are some more operators which are there here. For example, I will give you. You see, for every employee there is an age. Okay, you are having an age attribute. Like here, you see you have an age attribute. So I want to select, for example, all the employees who are male and whose age is greater than 35. Okay, can you tell me all the employees who are male and whose age is greater than 35 years? Can you tell me who is this? Tell me the name of the information about the employee who is male and age is greater than 35.
It's the name Tula.
No, this employee is female. I want male.
Salman, yes.
35.
No, not here. 25 male.
Greater than 35. Age should be greater than 35.
الا في موجود
35.
Okay. Yeah, see, it is taking a lot of time. Now you see, I will write a query, very simple. Okay, you see, select all from EMP. Okay, where e-gender is male. Okay, and e-age greater than 35. That's all. I just write and execute it. You see, this is the employee who is male and also age is greater than 35. Okay, I want to find out the name of an employee who is female and age is greater than 35. Here just I make female, correct, and just run it. See, it will give me. So there is no employee who is having the age greater than 35, right? There is no lady employee who is having age greater than 35. Okay, so let's take 25. Yeah, age is greater than 25 is only one female. Okay, so like that you can give different queries. You can filter the data. Okay, nicely. Now I will show you. This is from only one table we are writing a query. Okay, only this one table. But what happens if I have multiple tables? Then how we will write query for multiple tables? We will see. Okay, writing for multiple table. For that, first let us create another table called department. Okay, so I'm creating another table called department. So here you see create table DEPT department. Okay. So here I'm creating first department ID, DID. This is let's take this as an integer. See, department ID is integer, and let's make it as a primary key, department ID. Okay, so then next you have department name. This is varchar some 20. Okay. And department location. I write department location. This is varchar 20. Okay. And primary key. Oh, I will do one thing. For creating this department, let us keep primary key, no problem, because okay, let's keep primary key as department ID, no problem. Okay, let's create this. I just execute it. Okay, so now department is created. So I write select all from department. Okay. Tell me what is there in department. I created a table, but it has no rows. See, department ID, name, and location. Only these are the things, right? I have to insert some values inside that. So how do you insert the values? Insert. Okay. See the same thing. Insert into department values. Insert into name of the table is department values. Okay, first value is department ID. Second is some what is department name. So I give some name as content. This is some unknown department, for example, and its location is in Mecca. So let's see. Is it creating? Execute. Yeah, one row is created. You see, one row is created, right? Now, after this, when one row is created, let us create. I want to insert some more lines, okay, so that I can show you tables. So 1, 2, 3, 4, 5. You see, again, I want another called computer college of computer engineering department. It's present in Mecca, not Mecca. Let's write Jeddah. Okay. Now, can I insert it? Tell me. If I insert it, will give me error. You see why it will give me error? You see, it's giving me error. Why error? Because okay, this is same, but primary key is what? Department ID is primary key. It should not be repeated. It is repeating. No, I should not repeat it. I will give it 2, for example. Now, if I change this, now it will work. See, this is executed. Total, it will show me 2 rows. Correct. So like this, I will insert row 3. And I will give name as it's an EIE department. Okay, let us it in Makkah. Fourth, computer science. Okay, this takes CE as civil engineering. Okay, and this CS as computer science. Let us put in Riyadh. I'm just writing this an example. Okay. And 5, let us write, we have a support also department, 8,000. Let's keep it in some Chicago. And we have one more department, finance, FINANC, finance. Put in Medina, okay. See, all this I just inserted and just sell and execute. See, I have 2 tables now, okay. One table is employee table and another is department table, okay. So all these values I'm having now. So now we have total 2 tables now. One is employee table and another is department table. So let me show you this with new query. Where is new query, file, new. Okay. See, I have one query which is called as department, and here I will show you. Select all from EMP. You see we have 2 tables now. This is employee table and this is department table, okay. So we have total how many tables now? We have total now 2 tables, okay. So for this I think it is enough now. You just learn it. In next class I will show you how to write the queries for these 2 tables, okay. Like this you can take the same concept for 3 tables, 4 tables, 10 tables, how many tables you are having, okay. You can take the same concept for other tables as well. So any.
Thank you, Doctor.
Okay, so the important thing is you are supposed to first install this software and practice, okay. That's very important.
Yes, Doctor. I have question.
Yes, ask me.
Quiz tomorrow. Yes. Quiz
Yes,
2.
yes. Yeah.
Okay. Chapter from chapter 2.
Yes, yes. For chapter 1 we finished already, right?
Yes.
Yeah. So it is from chapter 2.
Just yes.
Yeah. Yeah. Diagrams.
Okay. Thank you.
Yeah.
And I have another question. The program. First,
Yeah.
it's me data. 64 bit.
You have 64-bit computer?
Yes, 64.
Okay, no
Because
problem.
Windows 10.
Yes, yes. I am showing you on 64-bit only. This is 64-bit installation only.
Choice after that refuse my computer.
Your computer is refusing after that? Yeah, maybe
Yes,
this is because because you don't have service pack. Install first service pack. I've shown you that. Go to instructions. They have given the link. Before installing SQL Server, install the service packs. Okay, install that. After that, get installed. Then install this SQL Server. It will be easily installed. Okay.
Doctor,
thank you.
Yeah.
for Doctor, for
Yes.
32 bits, the same link.
See, when you go to the link, it will give you 2 versions: 32-bit or 64-bit. You have to choose from there.
Okay.
Yeah. Is it clear?
Doctor,
So
now?
yeah, we will stop now and continue next class. Okay. Next class, I think we will be starting new sheet. Okay.
Inshallah.
Inshallah. So
Thank you.
welcome all of you. Thank you for your time. Take care. Yes.
For the homework, it's Thursday.
Yeah.
But we have report. Can you?
I think the homework time is finished, right? Is it there? Still time is there?
The homework 1 finish, but homework 2. Yes, not finish.
Yeah. So you want me to extend the time?
Yes, because the midterm starts now.
When you want? What is the time you want?
In the next week, can you?
Okay, next week I'll put next week. Okay, another assignment. Okay.